Ethernet switching is central to how hospitals connect devices like ventilators, imaging systems, and surgical consoles. The PB980 ventilator uses Ethernet to send patient data to monitoring stations. The StealthStation S7 exchanges surgical navigation data with imaging servers through managed switches. Valleylab FT10 uses Ethernet interface for diagnostics and updates. Switches make sure each packet reaches only its intended device, reducing congestion and preventing data loss. By managing this traffic intelligently, Ethernet switches maintain reliability and safety in medical networks. An Ethernet switch learns where devices are by reading their MAC address and builds a forwarding table. Unlike hubs, which broadcast data everywhere, switches send data only where it's needed. In hospital networks, this precision ensures clean, isolated communication between devices such as ventilators, computers, and patient monitors. Inside the PB980, internal switching ensures control boards and GUIs exchange data efficiently. This process reduces interference and latency, which is critical for patient safety. Switches use MAC tables to determine where to send frames. For example, within the Valleylab FX8, Ethernet connections link internal processors and service ports. When a technician connects a laptop for diagnostics, the switch quickly learns its MAC address to route traffic efficiently. These prevents congestion and maintains smooth communication between subsystems, which is vital in time-sensitive environments. Hospitals use VLANs to keep networks organized and secure. A ventilator might operate on a dedicated medical VLAN, while office computers run on another. The StealthStation Flex ENT, for example, can transfer DICOM data on its own VLAN to prevent interference with other systems. Understanding VLAN tagging and configuration helps biomedical engineers ensure safe and compliant device networking. Managed switches are preferred in hospitals because they allow network monitoring, VLAN setup, and diagnostic tools. Technicians can access which interfaces to verify port configurations or apply firmware updates. Unmanaged switches, while easier, lack control, not ideal for environments where uptime and traceability are essential. Power over Ethernet simplifies hospital installations by delivering both data and low voltage power through a single Ethernet cable. While most medical systems aren't directly powered via power over Ethernet, it's used for cameras and patient room monitors. Biomedical engineers must ensure electrical isolation and grounding standards are met to prevent hazards. Hospital networks use redundancy to ensure reliability. For example, surgical systems like the StealthStation S7 may connect through dual network paths to maintain data flow even if one link fails. STP prevents loops, keeping backup paths on standby. This design minimizes downtime, a non-negotiable in patient-critical environments. Each of these systems depends on Ethernet. The PB980 transmits patient metrics through hospital networks, while the FT10 allows engineers to update software over Ethernet. StealthStation connects to PACS servers using DICOM over secure VLANs. Each scenario relies on managed switches to separate traffic and maintain predictable communication. Troubleshooting begins with physical checks. Are cables connected? Are LEDs active? Next, ping the device or review switch logs for errors. On systems like the PB980 or StealthStation, verify VLAN assignments and IP settings. Document every change to to maintain traceability and simplify future maintenance. Ethernet switching is the unseen infrastructure of modern medicine. It keeps devices communicating securely and efficiently across the hospital. As systems evolve, AI will help predict faults and optimize traffic automatically. Understanding these fundamentals allows engineers to ensure safety and uptime across connected healthcare environments.